is a highly fatal foodborne disease. It's caused by Listeria monocytogenes bacteria, and it's mainly acquired through food. This study was carried out in New York State. You well know that in USA, most of the people eat ready-to-eat foods, and that's why they are very prone to this bacteria. This bacteria mainly affects pregnant women, the babies, newly born babies, the elderly, and the immunocompromised people. And it survives, the bacteria survives in a wide range of environments. So even if you just warm that food, you'll still get sick because it can survive in relatively high temperatures, relatively low temperatures in the environment. So the objective of our study was to find out the most influential habitat factors. I've explained that the bacteria can survive in wide environments, so we wanted to find out the most important ones, the most influential ones, and then determine their weights. We determine how they affect this bacteria. Then next, we would have to develop a model, a spatial model, that one can look at and know the hotspots of this bacteria. And finally, find out the variations in this model. In other words, we were to validate the model because someone will ask you which criteria you're using to show that this is the right model to use. To find out the most important variables, we had about 30 variables we were using. So I used the classification and regression tree analysis to find out to score them. So I can know that this is the most important, it has a high score, and this is the least important, it has the least score. And from that score, I would know the weight to give this variable, this factor. So from that classification analysis, I had this diagram, and it shows from top to bottom. It's not very clear, but from top to bottom, you'll see from this graph, you can know that this one scores highly, and then the last one scores the least. From that table, you'll see the scores in descending order, and their weights. After weighting these variables, because we have temperature, we have precipitation, we have distance to water sources, so you can't evaluate them at that level. You have to standardize them. So I standardized them to a common scale with a common scale of 0 to 1. 0 meaning that's the least importance. 1 meaning it contributes a lot to the survival of the pathogen. And all the habitat factors were in form of maps because the model was going to be in form of a map. Second was creation of the model, and I used multi-criteria evaluation because since you're not in that field, you wouldn't understand. But using this evaluation, I combine all these factors using their weights to come up with the model. And that's the formula I would use. So that's our map. The purple area, that, and that show the areas which highly favor the survival of the bacteria. These brown areas show the areas that are least suitable for the survival of the bacteria. Pie charts show how much each variable contributes to that area. So in this area, the pie chart will show which ones contributed the most and which ones contributed the least. So after getting our model, someone will ask me to prove that it's the right model. And I used a tool known as integrated uncertainty and sensitivity analysis, mainly for model validation, and it shows the variations in my model and what contributes to these variations. Because of the low performance computing devices we have here. I considered a very small area, and that's the area I considered, because if I considered the whole area, I would need high computing servers, which I didn't have. So I cut out this small area for validation. From the validation, I would find the sensitivity analysis and then uncertainties in my map. So the sensitivity surface shows the most suitable and the least suitable. It shows that up here, it's highly suitable, but at the same time, there are very high uncertainties in this area, and I have to prove why there are many high uncertainties, which factors actually contribute to this uncertainty. And these factors will actually be the most important factors that favor the survival of the bacteria. I hope we are together. So, I've explained from the uncertainty analysis results, I found out the most suitable area from up here, the most suitable area, which is that, and this same area has very high variations. And because of those variations, I'll have to carry out a sensitivity analysis. You see this red is big, it takes up a larger area, the largest area actually, and it represents the shallowest depth to the wet soil layers. So it shows that this contributes the most to the variations that I talked about. Blue is another big area. It represents proximity to water. Precipitation, which is this lime green, and then proximity to land, take up a smaller area. So I wouldn't consider them so much because of that. From this map, we can see from the key that proximity to water, the red, contributes a lot. The shallowest depth to a wet soil layer contributes a lot, and slope contributes the least. So from this, I can conclude that shallowest depth to a wet soil layer and proximity to a water body contribute the most to the survival of Listeria monocytogenes, and then the slope, which doesn't take up a large area here, contributes the least. But because it's the only one from about 23 other factors, my conclusion is that it contributes a lot if it interacts with other variables. So from this, water contributes the most on its own. So without anything else, water can actually support the survival of the bacteria. And then slope, if in interaction with other variables, will also favor the survival of the bacteria. So in summary, we've seen the most important variables, we've seen the areas at risk, because from that map, the people there will know that in this county, we have to be careful, because in New York State, actually, we considered it because so much farming is carried out there. So the farmers will actually be very careful when they are irrigating their crops from the water around, because I've already mentioned that the water contributes a lot to the survival of the pathogen. The recommendations were to treat their water. Because of the slopes there's need for collaborations. I'm a computer scientist, and I went into this to do this research. Other people did the lab work, and I did the spatial modeling. Future research should also consider real-time values. We should be able to just put in values into a tool, and then we have a map, and we know that this country is under serious trouble.